Hello everyone, I am MuskanGarg, a third year BTech CSE student at Bennett University. In this video, I will be talking about ethical versus unethical AI. So let's begin with the presentation. The pros of artificial intelligence technology have always been followed up with the cons of leveraging these technologies. With the launch of every new system that requires users to share personal and biometric data, a school of thought has emerged voicing the ethical and privacy concerns of using their systems. Google always promises us that the data we share with them is completely safe and secure. They say the mission is to organize the world's information and make it universally accessible and useful. But is this really true? Let's find out. Some of the products used for Google are mentioned in this slide. First, you can see there is Google Translator. It is a multilingual neural machine translation service developed by Google to translate text, documents, and websites from one language into another. It offers a website interface, a mobile app for Android and iOS, and an API that helps developers build browser extensions and software applications. Next, we have Google Maps. It is a web mapping platform and consumer application offered by Google. It offers satellite imagery, aerial photography, street maps, 360-degree interactive panoramic views of streets, real-time traffic conditions, and route planning for traveling by foot, car, bike, air, and public transportation. Then there comes Google Lens. It is an image recognition technology developed by Google designed to bring up relevant information related to objects it identifies using visual analysis based on neural network. Next is Google Assistant. It is an artificial intelligence powered virtual assistant developed by Google that is primarily available on mobile and smart home devices. Unlike the company's previous virtual assistant, the Google Assistant can engage in two-way conversations. AI presents four major areas of ethical concerns for society. First is fairness. Fairness includes protecting individuals and groups from discrimination or mistreatment with focus on prohibiting behaviors, biases, and basing decisions on certain protected factors or social group categories. Computerized assistive or decision-making systems have the potential to be fairer and more inclusive at a broader scale than decision-making processes based on Hawk rules or human judgments. Examples include measuring gendered correlations in pre-trained NLP models, equality of opportunity, and fairness in recommendation ranking through pairwise comparisons. Next up, we have interpretability. Automated predictions and decision making can improve lives in a number of ways, from recommending music you might like to monitoring a patient's vital signs. Interpretability is crucial to being able to question, understand, and trust AI systems. Some examples include Facets, which offers answers to the numerous challenges recruiters and hiring managers encounter, meanwhile providing job seekers and applicants with a smoother and more enjoyable candidate experience. Unfortunately, though the technology introduces solutions to common hiring problems, AI is often misunderstood, especially by the very people who stand to gain the most: hiring teams. These misunderstandings have been leaving many HR and recruiting professionals fearful of AI's implications. Has technology reached an unmatchable level that leaves jobs vulnerable and people replaceable? Fortunately, much of the fear around AI is due in part to the difficulty in defining AI. We want to break down those misconceptions by explaining three of the facets of modern AI, especially how each pertain to those in talent acquisition and the candidates they hope to hire. We will also uncover how those facets ease the hiring process and the specific tasks that overwhelm and frustrate recruiters, hiring managers, and job seekers. The third is privacy. It is essential to consider the potential privacy implications in using sensitive data. This includes not only respecting the legal and regulatory requirements, but also considering social norms and typical individual expectations. Examples are federated reconstruction, partially local federated learning, and TensorFlow federated machine learning on decentralized data. Next, we have security. It is essential to consider and address the security of an AI system before it is widely relied upon in safety critical applications. Examples include CAT-Gen improving robustness in NLP models via controlled adversarial text generation. Now that we are aware about the positive side of AI at Google, so let's move on to the dark side of the story, which is the unethical AI practices at Google. When the data we feed the machines reflects the history of our own unequal society, we are in effect asking the program to learn our own biases. We know that AI decisions are not always intelligible to humans. AI-based decisions are susceptible to inaccuracies, discriminatory outcomes, embedded or inserted bias. We need to focus on all of these parameters while creating an artificial intelligence environment. The person which you are seeing is Timnit Gebru. She is an American computer scientist who works on algorithmic bias and data mining. She is an advocate for diversity in technology and co-founder of Black in AI, a community of Black researchers working in artificial intelligence. Gabriel, a researcher at Google, had just clicked out of a last-minute video meeting with an executive named Megan, who had issued a jarring command. Gabriel was the co-leader of a group at the company that studies the social and ethical ramifications of artificial intelligence, and Megan had ordered Gabriel to retract her latest research paper or else remove her name from its list of authors, along with those of several other members of her team. The controversy highlights tension between the human and ethical consequences of AI development and the fact much leading AI research is underwritten by companies motivated by the technology's profit-making potential. Gabriel is a superstar of a recent movement in AI research to consider the ethical and societal impacts of the technology. She helped assemble and lead a small team of computer and social scientists dedicated to ethics research inside Google's AI research group. Gabriel says she pushed back on the treatment of her work out of concern for the future of AI ethics research at Google and people who work on it. You are not going to have papers that make the company happy all the time and don't point out problems, she says. That's antithetical to what it means to be that kind of researcher. Google Cloud's computer vision algos are accused of being biased. An experiment probing Google's commercial image recognition models via its Vision API revealed the possibly biased nature of its training data. Algorithm watch fed an image of someone with dark skin holding a temperature gun into the API, and the object was labeled as a gun. But when a photo of someone with fair skin holding the same object was fed into the cloud service, the temperature gun was recognized as an electronic device. To verify the difference in labeling was caused by the difference in skin color. The experiment was repeated with the image of the dark-skinned person tinted using a salmon-colored overlay. Google Cloud's Vision API said the temperature gun in the altered picture was a monocular. Tracy Frey, Director of Product Strategy and Operations at Google, apologized and called the results unacceptable, though denied the mistake was down to systematic bias related to skin tone. Typing donate bid prompted Google's algorithms to jump in with donate bid in Harris Act Blue as the top suggestion, a reference to a leading Democratic political action committee that has raised more than $2 billion this election cycle, according to the Center for Responsive Politics. Other suggestions on the list included donate bidden yard sign and donate bidden sticker. Typing donate followed by the first few letters of Trump or the candidate's full name prompted only the suggestion donate trumpet. It is unclear how many Google users might have seen the same pattern Wired did because of how the company tunes search results based on data it has about a computer's location and past activity. One of the most common interactions with AI technology is through virtual assistants in devices such as smartphones, which talk in standard white middle class English. Ideas of adding blank dialects have been dismissed as too controversial or outside the target market. The researchers conducted their own investigation into search engines and found that all non-abstract results for AI had either Caucasian features or were literally the color white. A typical example of AI imagery adorning book covers and mainstream media articles is Sophia, the hyper-Caucasian humanoid declared an innovation champion by the UN Development Programme. But this is just a recent iteration, say researchers. Stock imagery for AI distills the visualizations of intelligent machines in Western popular culture as it has developed over decades. From Terminator to Blade Runner, Metropolis to Ex Machina, all are played by white actors or are visibly white on screen. Androids of metal or plastic are given white features such as in AI and robot. Even disembodied AI from HAL 9000 to Samantha in Her have white voices. Only very recently have a few TV shows such as Westworld used AI characters with a mix of skin tones. Images of AI are not generic representations of human-like machines. Their whiteness is a proxy for their status and potential. The perceived whiteness of AI will make it more difficult for people of color to advance in the field. If the developer demographic does not diversify, AI stands to inflame racial inequality. Thank you.